is Yogesh Prasad. So like recently I have done my post graduation in SRM University Chennai. So like from VLSI designs. So as of now in layout, I have experience of almost 2 years. So if I'm including the training section, training part, and also I have experience in 3 nanometer projects and 7 nanometer projects. 3 nanometer in TSMC tech node and 7 nanometer and 5 nanometer in Intel tech nodes. So yeah, this is my experience. So currently, like I'm working in the Capgemini, India. So as a part of R&D department, and so currently, like I'm dealing with the Intel projects.
Okay.
So yeah. Sorry. Yeah, this
So,
is
like
what this is.
You.
Yeah.
Okay. For me, like I have 2.7 year of experience in analog level design, but actually due to career gap, I'm joined this this group for clearing interview. Nowadays hard to crack an interview because they're expecting more. So I have around year gap issue just so that due to that only I'm facing interview related in analog.
So year gap, may I ask like year gap due to like studies or like in what terms?
Not studies actually, some health issues and then like involving it with my family business. So
No, actually, why the reason of asking this question is because I have also like year like gap like my graduation. I have done my graduation in completed in 2015. So like I have experience in IT field also. So but
okay.
since I want to switch to VLSI domain, so like
Okay.
for that reason I did my MTech. So after that only like I switched to I was able to get the interviews for the VLSI domain.
So you are in like VLSI means working, like you are like Capgemini.
Sorry, I didn't get you, Amit. Come again.
So like you for like providing guidance or like you want to learn something more, you are here for. Your network is lagging actually, so maybe I'm not getting.
Yeah. No.
Your network is weak actually. Can you disconnect?
Can you join again?
Yeah, you can. You should join again.
Not in terms of guidance, of course. Like
we are not getting your voice actually, Yogesh.
Of course,
Yogesh, your network is bad actually. So due to
yeah, at my place actually.
You so what about you, Shindu? You can also like.
Hi, Amit. Yeah, myself Sindhu. I have a 4+ experience in the lab layout. So my last company was VLSI. Currently, I took a break from my career due to my health issue.
Okay.
Hello.
Yeah. Okay. You can continue.
Yeah. So, like what I was saying is, I hope I'm audible to all of you.
Yeah.
Guys,
Now
right?
audible. Now audible. Yeah.
Yeah. Please let me know because here my network issue is.
It's okay.
So, what I'm saying is, like of course, like I'm also searching for the job also, with better opportunity. So what I want to just say is like since I switched after the IT field, like after doing IT then tech and then coming to VLSI. So
Okay.
the thing is, the disadvantage was of course the what should I say, salary. Okay,
Okay.
like we'll be just straightforward for you guys. So they'll of course they'll not be considering the previous.
Yeah. Yeah,
So
they
hope
will
you
not.
guys like directly like Krishna and Sindhu. You both of you guys are like after the graduation you are coming right or
They are also experienced. I think Krishna is around 6 and Sindhu is 4.
Actually, I have experience in India. I came to US for masters. I completed my masters. Now I'm looking for full time.
okay, yeah, that's better, yeah. And Sindhu, what about you?
Yeah, I have 4+ experience in the lab layout. So from last November, I left my job due to my health issue. My last company was VLSI. I think people know about this because that company was started a very startup company. Recently, they started. My previous company is Capgemini, the known as Altron Technology, right? Now they are calling it Capgemini. Yeah.
Okay.
Yeah, previously we worked together in Ultra.
Yes. Now reality.
Yeah, so basically, so currently, I guess as of now, like we are like I already worked in that latest technology, but I believe like if I see in terms of job opportunity outside, so
I think sorry for the interruption. Your voice is not audible.
oh okay again,
I think you have an internet
just
issue.
yes
No,
yes
mic issue also, I think you were.
Yeah, maybe. So
okay.
you
This
both
time
are
mic issue.
working now for
Now I'm not working actually. My internship is completed in Infinite
okay.
Technology. Now I'm eligible for full time.
So it's still in your US.
Yeah.
When you will come back?
No, I'm not going back.
No idea.
I have to stay here.
Be there only.
Yeah, that's what I came here.
There's a lot of recession going on in India, so be there.
Yeah, so same thing happened. Yeah.
Okay.
Here one thing, we don't have any consultancies here and unable to get the job. In India, we have a lot of consultancies and startup companies,
Yeah,
right?
correct.
Here only we can find job in product companies only. Hardly 2-3 are startup companies.
Okay. So through
You know,
VLSI
when
only
we
you are
are,
going to switch.
yeah, I did my masters in VLSI only.
You completed, huh?
Yeah, I completed.
Super. So what about you, Amit? You are still working or?
No, actually not working. Actually, around 2 year gap happened. So yeah, looking for a job.
You also same case, Lokesh?
Sorry,
Lokesh is
sorry.
working. He is
Yeah, currently
working.
I'm working in Capgemini. So,
Capgemini.
Oh, which team you are?
sorry.
Which team you are? Team.
Team like as a person name you want to know or like the project.
Okay, let me know the
Start
team
asking the
leader.
questions. At least start asking the questions.
Sirus are not here, right? He's moved to
Questions,
yes.
but yeah,
Now
just
he is
start with the
working in Capgemini.
Okay.
Okay.
Okay,
We
okay.
can start question.
Yeah. Anyone have layout questions? Actually, I'm unable to download VLSI for all app. So anyone have those questions? They can share the screen and we can see, right?
Okay, we need to download.
Actually, currently I'm not prepared to come to this. So next meet I will come with all the things. Okay.
So just we discuss about the questions. That's it. We are
Okay.
not asking any questions. So I haven't seen those questions, so I have to see.
I need to check.
Are you able to
So
share the screen?
Oh,
Amit?
wait 1 minute. I didn't download it actually.
Okay.
Question we will start, then we will see with that once it will download.
You're gonna sharing the screen. You want to share the screen or?
No, we can start with other question. It will take time, few minutes.
Oh, okay. Yeah. Anyone have any questions?
One question I will start. Like how we are going to fix the height of a standard cell and how we will calculate actually the height.
It is based on the integer multiple of number of IP tracks output and power tracks. Based on that, we can decide the standard cell width.
Based on the metal track, how much we can inside the standards.
Yes,
so it's like if metal is starting with M0, so then we gonna calculate with M0, right?
It is not depends on which type of metal we have used, but it is depends on the number of tracks you are using. Is in any kind of metal.
Okay. So like how we're gonna fix actually for height? Because standard cell height almost fixed actually.
Yeah. Based on the tracks only they calculated about the standard cell.
Actually, how it will calculate like standard cell we will use in everywhere, right? Wherever it will be need, we can use. For example, NAND gate. If you are using only one time only, you have to construct all the NAND gate, right? So the cell height is fixed for everything. So according to that, you have to follow NAT, NAR, or everything should be in the same height. Then only we will not get any DRC. Then only we can continue the power line in the standard cell in the block level. You can get it right.
Can you repeat it again?
You're asking me.
Yeah. Actually, the standard cell height is integer multiple of number of tracks, right?
Yeah, correct. That is the answer. You are clear, right, Amit?
But how we gonna fix it actually? That I want to know.
Number of tracks of like which tracks you're talking about exactly? Like
no, I'm not talking about tracks actually. I'm asking like how we gonna
first we have to construct one cell. Okay, Amit.
Okay.
For example, NAND gate. Like the cell standard height is like somewhat 1.4 centimeter. Like this, you have to set. According to that, you have to follow all the NAND or not everything. All gates should be the same height. Width is not dependent on the cell height or width. Width is independent, but the cell height should be same for all the gate.
Okay.
For example, I have bit cell. How can you decide the height of the bit cell?
Bit cell, like how are you asking? I'm not getting. Come again.
In SRAM we have Y
bit cell, we will not do that, right? Like we are that is independent, right?
Okay, that's also we have to. It is dependent on height, right?
But we will not use in everywhere, right? But NAND and NAND or like this kind of standard cells wherever we can use it. Wherever the logic will come, we have to use, right?
Okay. It all depends on the track.
If I am wrong, please correct me. If anyone know, correct me. I don't know exactly. If you people know, please correct me.
No, actually, the answer seriously.
If you're not satisfied with my answer,
that
I will give you better clearance.
Actually, I need more explanation. Anyone?
Yeah, same.
For standard cells, like till now, like what I have worked. So what I've seen is normally like I've not worked on like the making of standard cells. Only the analog part I have worked. So for the standard cell which we have normally used, so basically it has the M0, M1 and M2 tracks, max to max M2 tracks. Okay, so at least they should have one VSS and one VCC track. So that they decide the height for M2. So you can say that it's kind of a Lego pattern. You can say smallest Lego kind of. So it's you can say that it depends on the designer, or not the designer. Like how am I supposed to say? Like I don't have the words to explain, but yeah. So mostly M2 tracks I have seen like max to max they have used. So it depends, like at least one track of VSS and one track of VCC. It should be there for the standards. I just want to give some one view of that standard cell.
Okay, but we have three kind of differential. Means one is like 3T, 60, 90, 12T. So what for that?
Sorry, 90.
Sorry, how many?
Like in normal scenario, we have a three kind of height of standard cell. Like one is like 6-track standard cell, second one is 9-track.
Okay.
Means depending on the length and width also.
The track, that means they are mentioning the metal, how many level of the metal they are using in the standard cell. That is the 3-track, 4-track like this.
Now you got it. So yeah, due to this is that's what the question actually. How are we gonna fix like how we going to use like 60 or 90 or 20?
That we cannot decide, right? Designer will decide that they will give in all the instructions. According to that information, we have to follow. That we cannot decide.
Yeah, that's what I also feel, but someone asked to me, so I feel it maybe this question going to ask with us. That's
For example, when we have the 9 tracks, 2 to 3 tracks we can use for IO pins, 2 tracks for power tracks, and remaining for signals.
No, it's not about routing actually. It's about height only. Just power we have like top and bottom. We can use ground and power. In middle also we can use power or ground, and routing also. It's like height. Miss one question I asked by someone actually, and I feel this is not our work to decide the height, because mostly we don't need to fix the height generally according to our layout. Like I did manual standard cell actually in my design. So mostly I did manually only, because in library 3 nanometer it was not actually standard cell. So mostly we have to design, and we just by parameters they like whatever we generate, and just we do in it accordingly, and almost it will going to fit only.
But who will decide the height of the standard cell?
That's what the question actually. Like it's about what power and like parameters, what parameters due to that we're gonna change.
So whatever you have designed, that will be used in the block level or what?
Block level only, in my block level only.
According to that, your lead knowledge only you have designed, right?
No, see, we have a 2 kind of standard cell. Okay, one we got from library, so they did design differently, right?
Yeah, right.
And like if in that design we are not getting, and we need to like put that some, like if inverter we have to, inverter is suppose like different parameter, inverter we don't have. So we need to design, right? But we can't design like that. So in normal, just like using PMOS, NMOS, and 2 bulb connection, and that's how we will clear, right? But in library, they design differently. So I feel the standard cell layout designer this question should be asked actually.
Okay, fine. Actually, what you have designed is one cell, right? One standard cell, right? So that standard cell should be merged with the library cell, or independently you are placing?
No, not independently. For my layout and my purpose only, I can use. It's
Customized
for all. Yeah, it's customized.
Okay.
Yeah.
Okay. So in that case, we don't need any designer knowledge. So you can follow your own, like
based on our layout requirements, we can build the
Actually, Actually, what I feel here, no one is like a standard cell designer actually. So they will answer better for this question actually. So that's why I'm not
Yeah.
clear. Yeah, because its answer is not perfect with anyone. And so where is this question from whom I'm not getting in that free master class interview question? Rajat, are you here?
Yeah, I am. Yeah, tell me.
Where that questions are there in like app interview questions?
Oh, you test series. Test series. Open the test series.
Acha,
Free
uh,
test series.
live test series.
Second.
Live test is that?
Second.
Live classes, live.
Second option. Second.
No, I'm not able to see.
First block is free courses. Second is free test series. Open the free test series.
Okay.
Go for the analog layout. And then you can.
Analog design. Analog design. No?
Analog
Acha,
design
no,
is also
analog.
there. Analog layout is also there. Both are there.
Okay.
You can share the. Okay, sharing will be not there. No problem.
Screen. It's not going to open.
No.
Okay, test.
Test it will like yeah.
Otherwise, can you share in chat? Chat also.
Yeah.
You don't have?
No. Wait. I'll try to share this. Share screen. Okay. Now visible.
Yes.
Okay. So first question is which pad contains synaptic triggers circuitry?
Actually, I'm unable to see your screen.
Question is not visible. Your screen only it's like blank.
I think it is loaded.
You are sharing your screen with everyone. Okay, I will share again.
We'll share it once again.
Okay, for sure.
Maybe security issues may be there.
Still the time. Okay, now you can.
Yeah. Open the app.
Now fine.
No. It has the security features. It has
Yeah.
security features. It will be not reflected now.
Okay.
Just
Krishna,
read the
I will
questions,
share.
no problem.
Yeah, you can
Acha,
read the question.
Okay.
Yeah.
Okay.
Read the
Okay,
question. Or
which
otherwise,
pad
can you
contains-
copy paste in
Copy paste is not there.
chat?
That is not.
Not there? Okay.
not.
It's
Yeah,
like
just read the question.
Okay, which pad contains schematic trigger circuitry? VDD pads, VSS pads, input pads, output pads.
It is multiple choice questions.
I have no idea.
It's about pad actually, like in top level they use some pins to connect with the outer means or say, I feel.
Which pad?
contains-
Come again. Read it again.
Which pad contains schematic trigger circuitry? VDD pads, VSS, input pads, output pads. I think
Input pads. Yeah, I think input pads.
Input is right answer.
Yeah, because wherever the triggering and all, we have to give the input right.
Once we start, it's outward to come. Which occupies lesser area? VDD pads, VSS pad, input pad, output pad.
Sorry, can you read it again?
Which occupies lesser area? VDD pad, VSS pad, input or output?
Output pad.
Right answer.
Because when we have the output area less, it will reduce the output capacity.
Acha, okay.
Yeah, it will reduce the parasitics.
Okay. Buffers are needed to drive a small capacitance, large capacitance, small resistance, large resistance. Buffers are needed to drive for what? A small capacitance, large capacitance, or a small resistance, or a small or large resistance.
Actually, the buffer function, it will send same data, right? Whatever we give the input and it will come same output. So when we are adding one buffer to our layout output, it will increase the cap, right? Am I correct?
I don't know. So,
No idea. from my side.
Buffer will increase the delay. Just
I do
not
it.
to say, but it will just it's used for the delaying purpose.
Yeah, when we got delay because of the parasitics, right?
Oh. Okay, so
Unnecessarily, we are adding load on the device when we are adding buffer.
okay, so it's for large capacity we need to drive actually. The answer is okay.
Okay.
Pad must be placed generally in the periphery of the chip area. True or false?
Pad must be placed in
Generally in the periphery of the chip area.
periphery of the chip area.
Periphery. Periphery of the chip area.
Again,
True or false? It's just yes or no.
True.
Okay,
But
yeah.
all chips we no need pads, but in some chips we are gonna add pads, right, to connect the bump connections.
Okay. So pads is just for outer world connection, right? So every chip needed, right?
It is depends on the layout actually. Sometimes when we are working on IO pads,
Okay.
that time in between two pads, just we are add digital circuits, either ring oscillator, any digital circuit. But in analog layouts, we are using pads for bump connections.
Okay. How much area should be allocated for pads? 1/3, 2/3, half, 3/4. Allocated area for pads.
What are the options?
1/3, 2/3, half, 3/4.
Maybe 3/4 when we are getting the pins out.
Wrong answer. It's 1/3.
On that, okay.
Circuit design concept can also be represented using a symbol diagram. True or false? True.
Symbol diagram.
Yeah. True. Yeah. True. Circuit design need tighter circuit, smaller layout, decrease silicon area, all of the mentioned. Need
All of the mentioned. Can you read it again?
circuit designers need for tighter, smaller layout, decrease silicon area, all of the mentioned.
All of them.
Okay. Yeah. Right. Process engineer wants smaller, tighter, reproducible, non-reproducible.
Process, right? Process means it is fabrication.
Okay. So
Fabrication.
reproducible. Oh, yeah, that's the answer. Yep.
Oh, yeah.
Maturity level of the process line affects design rules. Yes or no? True or false?
Maturity of the
Process lines affects design rules.
maturity of the process line means
I don't know.
I didn't put the definition. Maturity of the process line.
Same. Same. Design rule does not specify line separation, extension, colors.
What are the options? Colors. No. What are the options? True or false?
No. For which one? Previous?
No.
Yeah, design rule is not conception.
Design rule does not specify line width, separation, extension, and colors.
Extension.
Colors they specify, no? Colors they specify.
Yeah, they will specify, right? Based on the colors only, they will fabricate which mask first and which mask second.
For colors wise, the spacing rules are there. So
one is the extension and other one
separation, line width.
Line width is correct and color is correct and extension means what is that? Extension means it is the enclosure or
I don't know.
Extension is as a minimum length of the metal. Like it's a bit
I think that is the enclosure, VI enclosure, right? That we need. What is the one more option?
Separation.
Yeah,
I think
separation. I
separation.
think so. Separation. Yeah.
Separation. We can go for. Yeah, true. Yeah, colors actually. Sindhu, it's needed for design rule actually.
Yeah, fabrication also we
Yeah.
need.
Fabrication even
It's
need
7
for
nm, right? Below
Yeah.
7 nm, we have to use.
below 7 nanometer in 3 nanometer. So it's
Yeah.
colors actually.
There you are getting all the questions. Tell me, I will go to
This and VLSI from Rajat actually.
app.
Yeah, app. Yeah.
Okay.
Yeah.
Continue.
The width of N diffusion and P diffusion layer should be 3 delta, 2 delta, delta or lambda. I don't know. This is lambda. And for
what is the question?
the width of N diffusion and P diffusion layer should be
Weight of the
So,
width.
width of N diffusion layer should be
Width or weight?
width, length and width, no? That width.
Oh yeah, width. Okay.
Okay, so I'm not getting this question. What is this question actually? Anyone getting this question? The width of N diffusion and P diffusion layer should be.
Width of the end diffusion. Can you read the options again? Actually, I didn't read the question.
3 lambda, 2 lambda, lambda, 4 lambda. The answer is 3 lambda, but seriously, I'm not getting what is the question actually.
In basic formulas also we didn't see lambda, right?
Yeah, I don't know what. Not for review. Okay, what should be the spacing between two diffusion layers?
It depends on the technology.
Yeah, but here again 4 lambda, lambda, 3 lambda, 2 lambda. Spacing between two different
But
layers.
they didn't mention anything about the technology.
No,
right?
nothing.
They generally
No.
asking about the
generally
distance
asking.
between the diffusion.
Yeah.
Okay.
Yeah. What should be the width of metal one? Again, this is technology based question only. And plan again technology based. Okay, now which design method occupies or use lesser area? Lambda rule, micron rule, layer rule, source rule.
Metal width, right?
Which design method occupies or uses lesser area? Lambda rules, micron rule, layer rule, source rule. The answer is micron rule.
Micron rule means when we are placing the two metals side by side, then we calculate the space, right, between width of the metals. Then we calculate it in microns. That's why they mention micron.
Okay. Which give scalable design rule? Lambda rule, micron rule, layer rule, thickness rule. Scalable design rule. Which gives scalable design?
No, I don't know.
Okay, it's layer rules. The answer is okay. Device design with lambda design rules are prone to sorts and opens. Device designed with lambda design rules are prone to sorts and open. True or false? What is lambda design? Do you know anything?
No, I don't know. First, I don't know about the lambda rule.
Yeah, this is I think different.
We will read it.
Yeah. Diffusion and polysilicon layers are connected together using buttering contact, buried contact, separate contact cannot be connected.
Sorry, can you read that question? Diffusion and
polysilicon layers are connected together using butting contact, buried contact, separate contact cannot be connected.
But diffusion and poly contact is not connected, right?
Yeah, cannot be connected, right?
Yeah, cannot be connected. If it is connected source, drain, and everything, it is shorted.
Yeah,
Only source
short.
and drain.
Yeah,
Yeah.
source and drain. Yeah. Yeah. With source, it will connect onto that diffusion. Yeah.
Oh, yeah.
True.
No,
Which is
source will connect to diffusion.
yeah, source will connect to diffusion. Yeah. You have doubt?
Yeah, diffusion connected to source because it is we have to connect to the power connection, right?
No, diffusion is connected with no like in if you go below nanometer, so like MD or TCN is there, so it is connected with OD.
Yeah, we
Otherwise,
have the con.
otherwise it will floating only, na? Where we OD is just see, imagine where you OD will going to connect.
Okay.
It's connected with no OD.
No,
Source
if it
and
is connected, source also same thing, right? Source and drain top of the diffusion, right? If it is source is connected, drain also connected to diffusion.
yeah, connected, yeah.
Uh, but when we
Separate
connect
with,
output to the drain, then
but it will separated with that na polysilicon. No?
poly. Yeah. Yes, correct.
Okay, got it. Which is a more complex process? Buried contact, butting contact, buried and butting contact, none of them mentioned.
First, I don't know what is the butting
Yeah,
contact. Buried contact, I know. Buried contact means, yeah,
uh,
first we have, well, I
which
don't think so. Buried contact, when we have the anvil, that is the buried layer, right?
I don't know.
Deep anvil layer.
Okay, deep anvil, yes.
Yeah. Buried
But
contact and butt
deep
contact.
anvil is different. Like they're different device, no?
Yeah, different device. Yeah,
Which
this one is new question.
okay, yeah. Which contact cuts occupy smaller area? Again, this question: buried contact, butting contact, buried and butting contact. None of them.
Which contact? What is the question? Which
Which
contact?
contact cut occupies smaller area? The answer is both,
Okay.
buried and butting both. For
Okay.
isolation also same answer, both. Isolation layer between two metal layer must be thinner, true or false? Yeah, must be thinner, right?
Must be thinner.
Yeah.
What is the isolation layer between two metals? It is oxide layer only, right?
No, it can be depending on like shallow trench isolation we do. So it's like a
No, it is depends between. It is between the metals. What is the question? Isolation
yeah,
between the metals.
isolation layer between two metal layers. Yes.
Yeah, but STI is between the
Device
PMOS and
and
NMOS devices,
and must.
right?
Yeah,
Yeah,
yeah.
but here they are asking about in between the
Metal.
metals. But this is different.
So isolation layer, is there any isolation layer? I never feel any isolation layer. It's like we
When we
do.
route in layout, when we draw the metals, in between the metals, just we have the gap. They filled with oxide. With that gap,
Okay.
oxide is the isolation layer. But what is the option?
It's just true or false.
Okay. Question. In between the metals,
Layer isolation layer between two metal layers must be thinner.
it is true.
Yeah, true.
Yeah. Thinner
Okay,
means
the
they are asking about the oxide layer, which is the air gap between the two metals when we route. That gap they fill with oxide after fabrication.
oh,
So they are talking about how much thinner we have to place in between those two metals.
okay. The oxide layer below the first metal layer is deposited using diffusion method, chemical vapor deposition, solid deposition, scattering method.
Chemical vapor deposition we are using to deposit the poly. And
नहीं, chemical vapor deposition we do use for polishing actually.
It's polishing only.
Yeah,
Syllabus for
polishing.
polishing.
Yeah, chemical vapor
Oxide
is-
removal, right? Oxide
To
removal.
smoothing the surface.
Yeah, to smoothing the planarization for like yeah, for that one we use the
Chemical vapor deposition is for oxidization, right?
No.
No, yeah. This like
It's for
surface
just
flattening.
surface. Yeah, planarization.
For
we use.
planarization process?
Yeah,
Yes.
yeah. CVD.
Okay, CVD.
The oxide layer below the first metal layer. Okay, so it's asking just the question is how the OD will be going to fabricate. Which method? Diffusion, CVD, solid deposition, scattering method. So it's diffusion method only, no?
Oh, yeah, diffusion.
Scattering we use for annual, okay. CVP planarization, solid, I don't know what is diffusion. Yeah, diffusion. The answer is diffusion. Solid deposition, I don't know what is solid deposition.
Okay.
Which layer is used for power and signal lines? Metal, polysilicon, and diffusion, pre-diffusion. Okay.
Metal.
Yeah. So, minimum feature size of thick oxide is again 2 lambda, 3 lambda, 4 lambda.
The 2 lambda we don't know. The lambda rule.
Yeah, the lambda rule we don't. Hatching is compatible with monochrome encoding, bicode encoding, tricode encoding, not compatible with any encoding.
Matching, come again?
Hatching, not matching. It's
Hatching, okay.
Yeah, hatching is compatible with monochrome encoding, bicode encoding, tricode encoding, not compatible with. So the answer is, and we all don't know 3. That.
Yeah. Most of the questions from digital, right?
I think so. Yeah, minimum
Yeah.
annual again. Minimum annual width should be micrometer. So again 2, 3, 4. Hey. It's all green only. Oh my god. Yeah, I feel like we are clicking and it's all green. The answer how will go know how much we are. Okay, we need to stick. Okay, so we need to see. Okay, so which can bring about variation in threshold voltage,
Which can
Which can
which can bring about variation in threshold voltage.
variation in
mobility of
Threshold
the
voltage.
electrons. What are the options?
Oxide thickness, ion implantation, polyvariation, all of them mentioned.
all poly?
All of the,
All
Wait,
of
third one?
which can bring about variation
That
in
I got the question. Third option, what is poly?
polyvariation.
variation.
Oxide thickness, ion
Oxidation
implantation.
it will come, and the second one also will come. Third one is I'm not sure. Polyvariation,
No.
I'm not sure.
Polyvariation also because if we do doping to reduce the VT actually, so I feel all of them mentioned actually.
Yeah, all of them.
See, yeah, because if resistance is high, then we can't change the VT actually. So polyvariation must.
Yeah.
What are the advantages of design rule? Durable, scalable, portable, all of them. Advantage of design rule: durable, scalable, portable, all of them. Again.
No, I don't. You are unshare the screen, Amit. Yeah, it is
Unshare
not
the-
visible red screen.
Okay.
Yeah, you turn on the camera.
Okay, just we need to review. Actually, I feel that green was like true, but we need to finish. Okay, so
But interview questions not. These are the
it's not like
test,
interview.
right?
Test.
It is interview questions. They will ask about only questions, but it is a
It's like quiz.
type, right?
Quiz
Yeah, it is
section.
an-
Already I informed Rajat already
It's all are
informed.
related to digital.
Yeah, I
Most
mean
of the
that
questions.
is not much important actually.
Yeah, fabricated and digital related. There is no analog questions here.
Yeah, even analog question is very less.
Can you find? Do you have any other question?
Yeah, so yeah, matching. How we'll go for register matching? How we will do like matching register?
Yeah.
Yeah, interdigitization.
Acha, interdigitization.
Do you have any examples? You are asking about those questions or your own questions?
You're talking to me?
Yeah, it is your own questions or it is there in the app?
No, in my question only. I closed that app.
Okay. Yeah, we will use interdigitization matching for capacitance and resistance.
No, yeah. Capacitor for common centroid, register for interdigitization.
Actually, in lower nodes, we are not using any matching.
That is according to that
Technology.
DRM file. We have to. I think you, sorry, your client have not following this one, but usually they are going for. But there is a common right. So.
Okay.
I also didn't use interdigitization for register matching. We just placed.
That is requirement of client only. But but the standard followings this one.
Achha, okay, for register is interdigitization and capacity.
Yeah.
Okay. So Chindu or like Yogesh, you gonna ask some question or like?
Yeah, actually, like I have already doubt with respect to few topics. That is,
Your voice breaking.
Okay. I don't know whether. But let me just.
Remove the headset. No, you can talk directly.
Yeah, it's actually I'm talking freely, but I mentioned right.
Okay.
Network issues there. So my question is like with respect to the deep anvil and there is one more part. Yeah. So how many parasitics will be generated like in the substrate? How many parasitics diode will be there? Number of diodes.
Diode in the normal CMOS we have extracted 5 diode.
No. My question is like for the substrate, right? If you have this thing, parasitic capacitance, like it will generate basically the parasitic diodes. It will form the diodes when we are dealing with the substrate bulk connections and all these things. So how many number of diodes will be generated? So that is the question. Like I never understood.
In cross sectional, you are asking about in cross sectional or in cross sectional, how many?
If you have a CMOS, right? So normally we have a source, drain, source gate, right? And the bulk will be there and well. So
we have 2 diodes in. For example, we can take one PMOS or NMOS. Individual PMOS, we have 2 diodes. Those 2 diodes are connected in reverse bias. For example, I take inverter cross-sectional view. When the output, due to the noise, output comes down below the ground potential, then the emitter starts to emit the electrons to the collector. That time, the bipolar junction transistors will turn on. It will create the short circuit path between VDD and VSS. So due to that, we are getting the latch up.
Explaining latch up, right? He's asking something deep in.
Yeah, he's asking about the diodes only, right? Parasitic diodes.
Yes, parasitic diodes with respect to the substrate.
I think ask the question clearly, but what you are trying to ask, we are not getting clearly.
Yeah.
Okay.
Your question is how many diodes we have in mass?
Yeah. My question is like when we are dealing with the CMOS, right? So we normally give the substrate like the bulk connection, right, to the VSS or VCC, right? It
Okay.
depends on the PMOS or NMOS, correct? So what
Yes.
if, yeah. So first question is, okay, what is the reason for connection, giving the connection for the VCC or VSS for the bulk?
Okay.
If we are not giving the connection, then what is the outcome? Like, what is the result? What process will happen? That is the question.
Yeah.
What is
For
asking?
example, what is happening? Auntie?
What he's asking, I'm not getting. Tell me. Please.
Yeah. For actually, I'm confirming your question. When we have the PMOS or NMOS, we are not placing any guard ring or tap. What will happen? That is your question.
Yes, correct, correct.
Okay. For example, I will take the NMOS. For NMOS, if I'm not placing the guard ring for that, uh, the NMOS, we have the majority of electrons and minority of the volts. Due to the minority of volts, we are getting latch up. So, if we are not adding the guard ring or tap, we will get latch up. So, because of that, we need to add one tap. Means if it is NMOS, we need to add P tap. So, when we are adding the P tap to the NMOS, the minority charge carriers occurs from the NMOS. The tap will collect the minority charge carriers and it will discharge through the ground. So that is the advantage when we are adding tap or guard ring.
Okay, one more explanation I will do. Okay, so see, we always want to flow current between the source and drain actually. So if we don't connect with tap actually, what happens? The leakage will be start in the substrate actually. So there is no mean of like our purpose is totally going to destroy if we don't connect, and the body effect also will become, and VT may be vary, and we don't know where VT will go now. So we don't know actually VT if we don't connect with tap actually. So we always like, that's why we connect always source with the body terminal. uh, Due to that, we will not get any potential difference.
Yeah, to avoid the body effects
Yeah,
and VT
yeah.
variation
VT variation, yeah. So
and
VT will
latch up.
gonna change, and latch up
Yeah.
also, and basic operation will be failed actually. So output, what we going to design and what we expect output, there will be no output for what we are going to expect.
Without taps, we are unable to clean the LVS also.
Yeah. LVS is,
LVS and
yeah,
ARC.
yeah, that is latter issue, but yeah, we are not
Yeah.
going to connect because in schematic, like we have a bulk with source actually. We connect in schematic with source, or like yeah, source. But in layout, the body it's not going to connect anywhere. So we have to connect the
Yeah, it
body
is
terminal.
floating.
So it's, yeah, this floating actually. So it was a stamp conflict error also we will get actually. So because
Yes.
body terminal will be float, so it's not going to connect anywhere.
Without power connections, tap connections, ERC also not clean in LVS.
Yeah, ARC, yeah, many things, many problems are there. And DML, DNW, you asking about that question. What was that question actually? You want that layer or what?
No, so not that actually the concept wise I want to understand like how in the layout actually I never dealt with the
Deep
DNW
annual.
project.
Okay,
Yes,
okay. So, okay.
from
So,
the concept
okay,
point of view I
okay.
want to understand.
I will explain actually. So, what happened in TSMC? DNW is a layer actually. Okay. So, like antenna diode is a device. So, in TSMC, DNW is a layer. So, in that, it's like a square shape. Okay. Just okay. I have explanation. So, you can see that this color is deep envelope actually. Okay, so what
Yeah.
happens due to prevent latch-up issue, or like suppose if you have two envelopes, so you will connect with two different potential, right? But if we have only P global substrate, so if we have a two different bulk connection for NMOS, so it is not possible to connect actually. So what happened due to do that connection and like prevent latch up, like if we have any critical circuit and we don't want to route, we want a separate separate tabs. So we place in middle with that circuit, and we design like that. So like if suppose we have an inverter and we have to do that deep annual, so we will put two devices in there. We will do all connection in there, and taps also in that layer only. So yeah, that is deep annual. Hope you got it. If you have any doubt, you can.
Basically, we have to give a separate platform for the another NMOS.
Yes.
Yeah.
Okay.
And one more advantage when we have the different voltage levels, and means in my layout I have the 1.5 volt and 2 volt subblocks I have. So I need to separate from those two subblocks from the substrate. So that time I have used deep and well to separation. It is isolation layer.
Yeah, it's
Okay.
so Krishna, all fine. I explained well. Or
Yeah, well, but in analog they are expecting about when we have the different voltage layers, that time they're
okay,
asking isolation purpose, separating the two different voltages.
okay. So the main answer is when we have a two different voltage, then we will go for deep angle.
Yeah, deep and well is nothing but separate isolation layer.
Isolation
But
layer.
in some technologies we couldn't see that deep and well layer. That time
It's
we can use
TSMC
one.
only deep angle layer only.
In 5 nanometer we couldn't see that deep and well, right?
No,
Or,
it is actually in TSMC. It is that 3T DNW 4T
16 we have
NCA.
deep and well.
I am not sure actually, but in TSMC,
Sindhu, in 16 nanometer we have deep and well.
Yeah, actually I follow TSMC rules, so they have it.
Intel,
Okay,
I
actually,
don't
I
know.
remember that in Intel or something,
Intel is
we don't
customized
have
tool,
deep
they
and
will
well
not come.
layer. When we don't have deep and well layer, that time they will use P sub layer. Substrate something one layer is they use it for isolation
Okay.
instead of deep and well. That is the function of the layer also same as deep and well, but the foundry name is different.
Okay.
Okay, so it's P
Yeah.
plus layer in Intel.
P plus layer, no, P plus layer, P sub
Okay.
layer, P sub
P
layer.
sub
The
layer.
layer name is P sub layer.
Yeah, the means in that we just we create two diodes to tie just in deep angle. So that's all we can. It's just to create a means like a
Back to
tie.
back diodes,
Yeah, back to
back to
back.
back
Yeah,
connected diodes.
yeah. So anyhow we can design and like so maybe the name is
We usually when we need to connect the deep and well layer.
Deep and
Layers
well,
are
one is
three.
no. Actually, there are three terminal devices, right?
yeah.
Yes.
One
Yes.
is double substrate, second one is VDD, third one is VSS.
How it
Okay.
will connect?
Yeah.
Amit, do you have
Global
access?
substrate.
Do you have access? So can you share the whiteboard?
Don't access, but I can draw only, na? She have to draw.
Yeah, yeah.
Sindhu, you have
I
to
will try
with whiteboard.
subtraction and code. Whiteboard, I'm not getting that whiteboard.
That three dots and
Activities.
start this activity. You tell. I don't think so. There is.
What is this? She's sharing something. What is this?
Yeah, I'm trying to share my whiteboard.
Yes. From where you sharing this? Seven.
Are you able to see?
No, yeah, it's going some back.
Okay.
No, just explain.
Actually, the share option is it is not enabled.
Yeah. No.
How did you share?
I just with the share screen, 3 dot share screen.
There we can share only screen, right?
Screen, whiteboard, we.
Whiteboard,
Yeah.
I think it is not there. It is there. Huh?
Whiteboard is there. No, I don't think so.
Yeah.
Whiteboard is there, but
Well,
I couldn't share.
we are in US, so you never get extra option.
No.
Okay, you draw now. Better. Why are wasting time?
Yeah. Amit,
Yeah, what?
you can share and draw.
I
But
can't
I'm
share,
able to
na.
share.
You,
I don't have.
you
I
don't.
don't have whiteboard. I don't have whiteboard.
No, not whiteboard. Just share the screen.
Okay.
Take one word and take the snapshot and use for draw. Share the screen.
Otherwise,
Okay.
live video only you can draw in notebook. Yeah.
Yeah.
You must struggle.
Yeah, notebook better. So like just she can explain. no?
Yeah, like that only you can.
Okay.
No. In schematic wise, can you draw
Oh,
using diode symbol?
Back to back diode draw method.
I forgot how to draw back to back diodes.
Written your MS certificate here.
I also don't know.
Like this,
Yeah.
like this, right?
Hey, no, yaar. What is this nonsense? Opposite direction.
It has to be opposite.
I will Google
Like
it and
positive.
Opposite. All the collectors should be, both the diode collectors should be connect.
oh,
There is
No,
cathode.
connected emitter.
No, in diode, no collector. It is cathode.
I don't know, yeah. What to tell.
P-type will be connected like sharing this terminal.
So Yogesh, on which technology you are working now?
Yeah, currently I'm working in 7 nanometer Intel Tech node.
Achha, okay.
Actually, that is more tougher than the 3 nanometer TSMC.
No, it's easy. I worked on, man. Seriously, how can you say?
No, seriously,
Please.
no. Actually, recently they made update in that. So update in the sense like they introduced number of cells, and that to even to clear the base VLSI, it's very tough for it.
Actually, base DRC is different in 7 Intel. Actually, yeah, it is because but once you learn, it will easy. Actually, you will feel because
I agree with that. Like previously, it was good in the sense
Achha.
yeah, it's easy to clean. But I told you right. So recently, a lot of updates happened. So currently,
Okay.
what 7 nanometer Intel Tech node what we are using, that is it has a lot of different devices
lot of change.
and the PDK. They're all, of course they're updating the PDK files, right? So according to that, like
Okay.
yeah, we're struggling a lot.
Yeah, it's going day by day change. Yeah, so it's almost 3 years. So maybe they will update it. Yeah. So
Yeah.
worked on 3 also, 3 nanometer TSMC.
Yes.
Okay, so can you just describe its name in TSMC 3 nanometer? You remember?
What?
Layers in 3 nanometer base layers.
So base layer, like it will be same, right? Like even if it is 7 or 2. Like by name you're asking, or like
Yeah, by
RX,
name.
RX pin like that.
Yeah, by name I'm asking actually what layers.
RX pin, PC layer. Like
Right.
that. I think PC all 7 nanometer layers same only, right? 3 and
Same
also.
layers in 3 nanometer.
only only the name will be different. Like Envel, like I don't remember exact name, but yeah, like diffusion, pre-diff, and diff will be same. And instead of we have in 7 nanometer we have FTI. That
Yeah,
insertion
FTI is not there here.
FTI is there in 7 nanometer, whereas in that we use cut metals for the N0 layers.
In 3
Like,
nanometer FTI layer, no.
No. In 3 nanometer, we'll have cut metals. That in short,
Yeah,
we call it CM01 and CM. Yeah.
But cut metal is different. FTI is different.
FTA means 4 layer. Edge layer,
FTI
edge body.
is written, yeah. You are right.
Why we use FTI layer? You know, FTI layer. Why?
The
Actually,
purpose of
FTA has
FTI layer is to isolate the, sorry, to provide the insulation between the diffusion. It's kind of a diffusion layer, you can say that.
Yeah, to protect the diffusion, we use FTI layer. Actually. So it's like a LOD effect to reduce LOD.
it will break the
yeah.
OD when we are using FTA.
Yeah, yeah. No, not break the OD actually. To protect the OD, we can say.
No, yeah. Even to break the OD also use the FTI. That is also correct.
But for that, we can use poly also, na? For just if we need to break, then poly is sufficient for breaking the OD.
See,
No,
poly.
for example,
No.
What is
Actually,
poly?
One, please.
actually,
One
in
by
below
one.
nanometer, OD is continuous, right? So there is no need to protection, right? So we need to cut.
Yeah, that's why we don't need. Yeah, it's correct and sure. In 3 nanometer, the OD is not. The OD is always continuous. There is no break.
So that even 3 nanometer we have metal diffusion, right? MD layer, which we say. Whereas in 7 nanometer Intel we say TCN layer. It's same kind of metal diffusion.
TCN.
Yeah, so metal
Yeah,
diffusion
TCN. We are
for the
different.
heat
Yeah.
protection we use, right? So,
Yeah. That seaport layer, what contains actually? Seaport layer.
sorry, which one?
Pod layer.
Pod layer. Seaport called, na? That.
it is dummy
Yeah.
poly.
Yeah. So that like dummy poly and dummy oxide also dummy, na? In dummy in seaport contains dummy poly, dummy oxide, right?
Yeah,
Okay, for pod layers. Oh, okay. Yeah. So
pod
that's
gate.
for
Pod gate.
yeah. That is for dummy devices. So it's just a layer to understand to understand so that tool can understand that okay, this particular device is a dummy device. For the pod layer, right? POD.
Yeah,
That is
that I got. That layer contains like dummy poly, dummy oxide, and dummy diffuser.
Not dummy diffusion. It is dummy poly.
diffusion won't be there. That's a dummy poly only.
Dummy poly only, not diffusion.
Dummy
It
poly
is there
oxide
an
also.
active.
Okay, dummy oxide also it's content, right?
No, it
Dummy
is a
oxide.
dummy poly
There
only.
is-
Only
there
the
is no
difference
dummy
between active
Oh.
poly and dummy poly. Only that pod gate is difference.
MD is
When
also
we-
there, na? MD is also there, na?
Yeah, dummy
Metal
MD is there.
diffusion.
MD. Yeah, metal
That is for metal diffusion. MD is called metal diffusion. So basically, we'll have the diffusion layer, right? So and on top of diffusion, we'll have two types of connections. Basically, that is poly connection. That is polysilicon oxide that is used for gate, and then we have diffusion layers. As which diffusion layer? Sorry, metal diffusion, metal connections.
Okay.
And yeah, what else? So that is for I guess source and drain.
Okay, so one more thing actually. So if you just remember, once you turn on right or left that seaport layer, then it's the oxide is little increase, right? The diffusion oxide it's gonna increase, right? True.
No, it is same
Diffusion, no,
idea.
No.
I
That
don't understand.
the oxide diffusion is going to increase once you turn on the pod layer.
Okay, that
Yes.
I'm not sure exactly.
I'm sure actually it's it's minor increase actually that diffuse that oxide. That's why
Okay.
asking its content or like dummy oxide diffusion.
Okay.
Okay, fine. No, sure.
I don't think so. It is not increasing the body height when we turn on in the pod.
Once we turn on, it's increase actually.
If it is increased, we will get body DRC, right?
No. What happened? Once we merge with the device, it will disappear actually.
Oh, okay.
But for corners, na, like see, once we corners, we will what happens? Suppose corners layout, it going to reflect like that. Actually. So it's just like what to say. In corner, it look like this. You can see now. So in corner, actually, OD is there.
Okay, once we are abutting, that will disappear, right?
Yeah,
That is no
disappear.
problem.
Yeah,
We will
yeah.
not get any DRC.
Yeah, we will not get it. It will kind of merge, or you can say disappear. Mostly disappear, actually.
Actually, FTI, the function of FTI, actually, I did two subblocks. Lengths I have terminated with FTI. In top level, I integrated those two subblocks. So if I place side by side, if I merge with FTA, then I got OD break between two subblocks because I merged with FTA, right? Otherwise, we can give the poly pitch between two FTAs. That time we need to add dummy TCN between two FTAs.
FTI generally we place where the OD is like we have to break only. There we can
Yeah,
place. Yeah, there we can place.
it will protect the LOD and it will break the OD.
Yeah. No, not how can say break. Poly we can use if we need to break. Then
No,
poly.
when we have the FTI, we don't have the poly.
No, poly over the poly only we draw
But
the
I am
FTI.
talking about Intel.
Yeah, I'm talking about Intel only.
Yeah, on top of poly only that AI layer will be there.
We draw
Dummy poly, right? That one?
Yes, that will be
Yeah,
dummy.
that
Yeah,
dummy
dummy
poly.
poly.
It will
Yeah, that dummy poly.
actually poly it
But
will do the DMC.
I'm sure it will break the OD.
Yeah, of course. It's a OD breaker also.
Yeah, obvious. Maybe it is possible.
It will break the OD. That's what we are not using FTI because when we don't want OD break, that time you are not
Yeah.
using FTI.
Mm.
It is entire the top cell. That time at the top level, we can turn on the FTS edges of the layout. That time it will protect.
Okay, so Krishna, I share with you na, that and the second answer. What do you think about that? Because I'm gonna little confused actually.
Actually, calculated the current, right?
You last time you calculated the resistance of the device, right?
Yeah, resistance of the device. But
But it is possible to calculate the device resistance. It is not possible, no? Because poly have different seat resistance, oxide have different seat resistance, so it is hard to calculate the.
But in your question, they're asking how to calculate the IR, right?
Yeah, how to calculate the IR? Yeah, so I asked with the experienced person, and like he is telling this answer actually.
But R is equal to rho L by A. Rho L by A is equal to width into thickness, right? Thickness is not in our range. So we have only option R is equal to L by depth width.
Okay.
So we know the width and we know the length. Based on this, we can calculate the R.
But are you sure? Because seat resistance is major factor. If it's just suppose it's taking V1.
It is depends on the material which material we can use in layout, right?
Yeah.
It is not in our hands. Already
But-
they designed the materials.
Okay, fine. But just think if we have a device, if we have a PMOS, so we have a source drain. Okay, so how are you gonna calculate the length actually? Because source length is different because by poly we gonna break, and poly resistance also we have a different. He just told me that no device resistance we can't calculate.
Okay, this is for parasitic. Yeah, airdrop is also metal related, right?
Yeah,
It is not
metal
device
related. Yeah, device
now it is
related.
fine. Yeah, it is fine. It is
Yeah.
metal related.
Yeah, it's metal related. Actually, I confused. Actually, once he told me like that, so I confused. But later I feel okay because we have a sheet resistance of different metal and
No, he is calculated based on the device. I calculated based on the parasitic based on the metal resistance.
but I feel so you can't calculate by device resistance actually.
Yeah, we cannot calculate. I calculated metal resistance. It is the parasitic resistance.
So I think the answer is fine. That answer, right?
Which one you?
Yeah, which I shared with you.
Except that is a device related.
But Sindhu, can you come and like one question like can we calculate device resistance if we have team of
That is the purpose of the multiplier, right?
what?
Give you that example question.
Like that same question.
Yeah, same one.
Yeah, just okay. So like we have a 2 milliampere current, okay, and we have a 100 finger device, and to 1 micrometer. 1 micrometer width is there. Yeah, so we are going to calculate
1 micrometer, right?
Yeah, 1 micrometer. Yeah, 1 micrometer. And we need to calculate EMIR. So the question is like about calculate the means what metal we are going to use, because 200 milliampere given is there. So what kind of widths we are going to provide for that layout, right?
200 milliampere, right?
Yeah, 200
milliampere. Actually, Sindhu, I calculated this one. Yeah, we try to calculate.
Current we can calculate like they given the area, right? 2 micrometer, right? Length.
1 micrometer.
1 micrometer. So
yeah.
I don't have paper and pen here.
Yeah, actually, Sindhu, I calculated, right? We have the current is equal.
There are two formula we have to use. For resistor, we have to use different one. To find the metal length, we have to use the different formula.
R is equal rho L by A.
That what you are telling for this? That we find for resistor.
Resistor, right? I know the length 1 micrometer and I know the width. The width is number of fingers, right?
No.
They already have some length and the current carrying. Current also they have mentioned, right? In your question.
Current, 200 milliampere.
So whatever you know, you write it. I will tell you.
Is equal.
So whatever you know, you need to find. Keep it in left side. Okay. Equal to whatever you know. They have given the metal width and the current, right? For how many micrometer you have to find that? Sorry, how milliamps? 2 milliamps, right?
200 milliampere with 100 finger device.
So what? So divided by 200. Like 2 micrometer into some current you have told, right? Divided by 200 milliamps.
200 milliamperes divided by?
No, yeah. Division, that 200 will come under. Okay. Upper value we have already knows, right? Some metal will carry some current, right? In your question.
Which formula you are using? No, that is also not mentioned.
Actually, we will not use any formula. So this, to find this length, our own we have to find that metal, how much, like this width of metal will carry this much current.
But so length already given, right? Length is equal to 1 micrometer. Sindhu, they gave current, width and length. So then we calculate EM and IR.
Calculate, no. They already given, right?
R is equal to L by W.
Ah,
Here we can find resistance. L is 1 micrometer and what is the width? Width is 100 meter.
that only I'm telling, yeah. How can I do? Otherwise, you send me snap in WhatsApp, I will tell you.
Yeah, okay, yeah, it's will better.
Because I came to my native that I don't have any sources.
Krishna, actually, see, I feel so like, okay, we can't don't think so.
Okay.
See,
So
this
it's,
resistor and all DFM file will given. Okay.
yeah,
So,
given. So
the metal we will
for
decide. We need to calculate our own.
Yes.
Yeah, that I got.
They already mentioned, right?
Because see, he mentioned like 100 fingers, so like he want like 10 you place and how many routings we will do, and like how many tracks we will do, and what with that metal we will use that. I feel so because device there is no mean for device because EMIR we don't calculate for device.
Okay.
Yeah, right. Only we calculate for metal only, na?
Yes.
Metal.
See, yeah,
Both are metal problem.
yeah, metal
Yeah,
only.
if it is a 100 device, 10 cross 10 we can place, right?
10 cross 10 we place, okay, and 10 metals also we can easily, all 10 or maybe 20 also. But
Yeah.
if we just take example of 10, so we can calculate minimum weight of one metal, right?
Yes.
So that gonna be answer, and I need to study again because I still I didn't understand well.
No, if we calculate IR, we need to find the resistance, right? How you find the resistance?
According to that, we have to follow, right? Which the parameter they have mentioned in the questions. According to that, we can calculate. For example,
we
they given the
calculate?
resistance.
They didn't give the resistance.
We have to follow the resistor formula is equal to W by T.
Yeah.
That formula we have to implement. Current we can go for I is equal to Imax into some value they have given,
Yeah,
right? That we can.
RS into W minus like something in
Yes.
DRM file we go for
Yeah,
that.
yeah.
Yeah.
Oh, here they expecting to calculated EM. Means Excel sheet they will provide, right? EM.
Some will, yeah. EM, some DFM they will provide. Not all.
Yeah. That IMAX, not that for
IMAX.
IMAX, right? EM is equal to IMAX, no, right?
IMAX or I average? I average.
No, IMAX. Same. Both are same.
According to the DFM, not a big issue.
No, single I have question. They calculated. They provide.
I think location is very. Yeah.
Guys, I'll be sorry guys.
Okay.
Okay, lo, you get
Let me meet next time.
Yeah.
Yeah, sure.
Okay.
Yeah.
Bye.
I'll be sharing my project also, what I'm doing, so in that case we can discuss.
Okay. Sure.
Okay, yeah, we'll leave it. Yeah, thank you. Bye.
Thank you.
Bye.
Come again.
Yeah.
Krishnan.
When we are starting the layout, they will provide us one Excel sheet, EM/IR calculation, right? How they calculate that the sheet?
They have own standard. How are you asking, Krishnan?
See, okay, no. Wait.
Is IMAX
I will.
current or I average?
IMAX. Okay, so one IMAX is equal to.
Yeah, same question they asked me in interview.
No, IMAX only.
How
they
you
will-
calculated the EM value?
Come again. How you calculate?
How you calculate the EM based on average or IRMS?
IMAX. Actually, how I calculate in the TSMC 65 nanometer, they have some sheet. Okay, one standard value. For example, M1 metal should be this much temperature only it will be carried. Like this, they will provide it. How I will calculate I is equal to Imax into the temperature they have given. The respective temperature, we have some value, Imax value. So we have to substitute that value According to that, we have to calculate. You got it right?
Different temperature
Actually,
have different seat resistance.
Different value, correct.
what is expecting from me, right? Which formula you are using to find the M, to solve the M?
I is equal to I max into some standard value like 0.369 like that.
Like seat resistance, we
Some
can say, right?
constant value,
See-
right? Some
see-
constant value.
Yeah, no, it's depending upon DRM file.
Yes,
Yes.
DRM file.
Yeah. So it's we can say it's a seat resistance in seat resistance or like
that standard value, I don't know how they are managing because every formula and every temperature,
like
that standard value is different.
okay, like every metal has some seat resistance. Okay, so that is I think that is seat resistance into W minus some minus actually 0.06. So I think that is by process variation the metal will be this.
Correct.
So
Yeah.
that they will minus actually. So I feel that is the that is the answer. So seat resistance into W minus that minor process variation happened in that metal, and by multiply with that we will calculate.
Yes.
Okay. The formula is same. The standard values will change to
Yeah,
According to
with
the
temperature
according to
and
Yes.
temperature and metal. That
Yes. Mm.
okay.
yes. Yeah. And for IR, how we will gonna calculate IR? What we needed for IR?
IR the same formula she told, right? Resistor we can use that formula.
It depends on the width and the length of the metal, right?
According to that means
It is depends
Actually,
on
yeah, length also, but length is not like in TSMC, some PDK, like if length is 20, below 20, then fine. And if it is below 5, then that is different. So we are length also, but if below 5, then we will change the formula. If it is up to 20, then we have a normal formula and it's up to 20, then again that 20 will be. I will share one video with you, you will see it.
yeah. Do you have any videos related to EM also? How to calculate the EM? Yeah, we will discuss about it.
EM only I'm telling, not IR.
Yeah, EM is.
Yeah, EM only. EM only I will share with that. So Sindhu, like you are facing interview issue or like you are not getting an interview or what kind of problem you are facing?
I already got the offer, but it's
okay.
like conditional based offer. Like once we have to clear the client interview, then only they will give it. Like
most of the
yeah,
companies.
most of the companies are doing like that only. All service based company doing that.
Yeah, like that only. Yeah, when the
After clearing the client interview, they will give offer.
They will give offer. Yeah. Actually, one offer.
They already released the offer, but they are not giving any salary. Once the client accepts you, then only.
Okay.
Oh.
Yeah.
But they are not the part of that company.
Which company? Which company?
This one, Mirafra and Saikatya.
Okay. Okay.
Yeah, Marafra, it will do like that. Once
Most
they will, finding itself, they will laid off Marafra. Yes, same thing is happening to my friend. My friend is joining Marafra. 2 months she's on bench. After that, they will say we can.
It's better here. Yeah. Sitting in the bench, we will go somewhere.
So it's better to go on direct work, no? So it's better. Yeah, who will gonna face that kind of a seriously? It's that and resume is also.
Here actually interviews are easy, but openings hard to find.
Okay.
Super, yeah. Once you find
any opening in Intel, Krishna?
Schedule the interview, it will clear. They will give the offer.
Once you got refer me also, I will come.
Yeah, I will refer.
Intel, you got means any vacancy is there in Intel?
No.
Krishna?
No way.
If in Intel, then let me know actually if there's any vacancy.
Oh, you will refer?
Yeah.
Actually, Intel I don't have. Only
Actually,
I have.
Intel condition is not very good actually. Now they are decreasing the salary and no projects means, so due to that they are not hiring anyone and no people are going.
Okay.
But let me know if there is any like
Yeah, sure.
with your experience.
Yeah.
Okay, so Sindhu, you
Oh.
have any questions? Or-
Then what else?
I feel done for today.
Yeah, sure.
I
We'll meet again.
yeah, sure. Because I came for the trial, how the interviews are going to see that only I came. First time, this is first time. So I don't know. So for blank only I came. So next time I will prepare and look through.
Yeah.
Okay. Yeah.
Actually, Amit,
Yeah, so many
prepare
things.
for nodal analysis in Cadence. One of my friend in India, he has attended to Cadence interview. They asking about nodal analysis. He's reverse. He's asking the question to interviewer, why you are asking nodal analysis.
Okay.
he's telling we are working on RF layout, so we need to know how to calculate the current.
Okay. Serious.
Nodal analysis. When in BTech first year, I have seen this nodal analysis.
Now for me, like
Only
one
one
previous
question
person
she
is
is
like
asking,
two
and
I-
okay, you are not fitting for this position. You can go.
Oh,
Oh my god.
RF layout, we need this IR related questions, circuit related questions, and nodal analysis.
Okay.
so I will ask one question.
Yeah.
Okay.
End up this one.
Okay.
Why always poly is affected due to the antenna? Why not source and drain?
Okay. So poly, we have a oxide layer actually. Source and drain, we don't
And
have
drain,
any
we don't have
oxide
oxide layer.
layer. So that's
If
okay.
anything
Yeah.
happen
One.
in source and drain, right, we have the diodes in reverse bias. When we are getting higher amount of charges, those charges, reverse bias
Discharge.
diode will conduct and it will discharge to the ground. We
To
don't
the
have any
ground.
problem with source and drain.
Okay. I will add one question more. So how charges will accumulated on the metal plate?
Okay.
Actually, yeah.
Wait, I'm thinking accumulated on the. Okay.
After doing the fabrication, the metal will
No.
will mean bump and
Actually, why we are going for jumper like that only it will come, right?
yes.
No,
How we are
no, no,
using like
no, no,
jumper, right?
no. The question is how from charges how it's coming on metal.
Yeah, same question here.
No. I got it, but the jumper only I can explain. But this one.
Okay, fine. Explain. Example,
Jumper,
you
no.
will explain like manufacturing, then we do planarization.
What are the application?
Yeah.
It will go
But
by the
That
step.
we know. Yeah, what they asking, right? When we are route long metal to the gate, right? The charges are accumulated. What they asking? How you get those charges on that metal, right? That is
from
your
where?
question.
How?
From
Yeah.
where
Where
the
did you
charges
get
are
those
coming?
charges?
Yeah.
Yes.
From where the
During the
how
process,
they-
I think.
No.
What
Same
yeah.
question, yeah.
Hey, that we cannot tell. Yeah, seriously, that will come in the fabrication point of view,
Yeah.
right?
It's
How
not
will
in our
Yeah,
hands.
but we have to know na how like see some question like they ask like antenna latch up. So like sometimes
I asked my
they
team lead
will-
also, he's telling like that only, but nobody's giving their point of view. So I also following the same one.
but they will sometimes they will go deep now. Okay, so let me know how that charges. Means very rare people ask, but some people ask this question actually. How the charges are coming on that metal? Actually. How what happened in this fabrication process? Due to that the charges are coming on that metal plate. Means what happened that time?
whatever the knowledge I gained from myself, I will tell you, but I don't know exactly, but I will tell you. Okay, plasma etching in the sense of like
Got it.
hot ionization, right? Hot ionized the gas, right?
Ah,
So when we are doing the fabrication time,
Hmm.
so we have to focus on the particular place where we have to fabricate, right? So that time all the charges are coming in the metal layer. So whatever we are giving the particular point of the gas, that will go in this material, that metal only. So that metal is connected in the polygate. Okay. So I think like that only, but I don't know exactly.
Okay, I answered same actually. What I answered actually. So, while fabrication, like if M1 is going to fabricate it, so that time the heat is very high, like temperature is very high. So the charges will be auto generated, like due to that
Auto
heat.
generated.
Like yeah,
Oh, yeah. Auto generator will come in the EM only.
or not autos, and that term I didn't use. Like manufacturing it charges will be coming by manufacturing that M1 metal or like any metal. Because
Okay.
too much
We'll
heat
give
is
a
there.
better
Yeah.
Actually,
clarification.
I
on
don't
it.
know.
Yeah.
Yeah.
Yeah, I also don't know. I'm just
We'll give a better
like
explanation.
we have to ask this question actually. I am facing from this question actually from my training period actually.
Okay.
One guy asked how, so he will tell, okay, go and find, go. Still I'm finding this.
Still you're finding. Good, yeah. Nice. Good process.
Yeah. Okay, so I will. So good to talk with you, all of you. And now we are done.
Samit, where are you?
UP Gorakhpur.
Okay. Staying on the living on
Yeah,
the
hometown. Yeah, hometown only.
there. Okay. So we are looking now.
Yeah, looking for a job.
Okay. So previously where you have worked?
Testall Semiconductor.
Oh, it's all okay.
Hmm.
In
Bangalore.
TESOL, we have layout positions also, or it is all
I
related to testing, right? The company.
all people are bench only in Testall. All my friends are bench.
Mostly
Oh,
layout people all are bench.
Even
Okay.
HCL, many people are in bench only.
Okay.
Okay.
Hmm.
So how long you are been not going job?
What?
How long you have gap? So when
2
you
years.
get the job?
2 plus. January 2021 was last.
Till now you didn't get any job.
I didn't look actually. I'm looking from November actually, last November.
Okay.
So that time from
Okay. Fine.
from that I didn't get.
Mhm.